Now I like to explain the frequency of intermolecular collisions with the like molecules and with unlike molecules. Say frequency of intermolecular collision means it is the collision, it is the number of collisions made by the molecules in unit volume in unit time. In case of wall collisions, it is taken this unit area, since in that case it is the 2 dimension, and here space means 3 dimension. Instead of area, we can take this 1 unit volume in unit time. The number of collisions is given the frequency of collisions. So first we like to start frequency of collisions, frequency of collisions with like molecules. This is represented as Z11, means it is the number of collisions made by the molecules of unit volume of this gas in unit time. So it is represented by Z11, same time, like molecules or similar molecules. So in this case it will be, we have calculated that this Z1 equal to root over 2 pi sigma square and C bar n dash. So for this case, n dash, suppose it is n1. The n1, or let's say it is n. It is the number density of this molecules. C bar is the average speed, sigma the collision diameter. So here it will be Z1. It is the collision made by a single molecule in unit time. But in a gas, there are n dash type of molecules. So when n dash, so for part cc, when we shall determine, then this one will be multiplied by n dash. It is the frequency, it is the number of collisions made by single molecule in unit time. This is and n dash is the number of molecules per cc. So whenever it is multiplied by n dash, then this product will give you the number of collisions made by the molecules in unit volume in unit time. But one thing I shall have to modify. Say if we multiply this n dash only, then the calculation becomes one collision is calculated twice. To avoid the double counting, it is to be divided by 2. Since 2 molecules will make 1 collision, so the number of collisions will be n dash by 2. Say, I shall show you one example. Say there are 3 molecules per cc of this gas, and we are considering the binary molecules. So this molecule will collide with this one, 1. This molecule collide this one, 2. This molecule colliding this one, 3. This molecule colliding this one, 4. This molecule colliding this one, it is the 5, and this one making this collision with this one, 6. But actually, though there are 6 collisions we are counting, but this collision and this collision and these collisions taken as 1. So total collisions how much? 6 by 2. 2 to be divided or half to be multiplied in order to avoid double counting. So This one will give you this root over 2 pi sigma square c bar n dash into n dash by 2. So this will give you 1 by root 2. 1 by root 2 pi sigma square c bar and n dash square. This will be the frequency of collisions with like molecules. So this one also, say suppose in oxygen gas, this will be the frequency of collisions between oxygen molecules only, but in case whenever it is in nitrogen gas, it will be the frequency of collisions between nitrogen molecules per cc or per unit volume per unit time. Now we like to calculate. So here I can write this one equal to Z11 and root over 2 and pi sigma square c bar and n dash pi. Now I like to calculate the frequency of collisions between two unlike molecules, between two dissimilar molecules. Say in air there are oxygen gas and also there are nitrogen gas. So total collisions, how much will be the total collisions? Z equal to Z oxygen, oxygen plus Z nitrogen, nitrogen plus Z oxygen, nitrogen. This is the frequency of collisions between like molecules. You can calculate from this formula. This one also frequency of intermolecular collisions between like molecules. You can calculate here. But how would you calculate this one? And it is very important in chemical kinetics. Suppose one iodine molecule is colliding with this hydrogen molecules to form this HI, hydrogen iodide, collision theory of chemical reactions between oxygen, between hydrogen and nitrogen, between hydrogen and nitrogen, and between hydrogen and iodine give you twice HI. So these two, hydrogen and iodine, in gaseous state they will collide, and this will be intermolecular frequency of intermolecular collisions between two unlike molecules. This is to be calculated. So instead of this, we can write Z11 plus Z22 plus Z12. This one to be, we have to find an expression for the frequency of collisions between two unlike molecules. So how could you calculate? Say Z1, this one is given root 2 pi sigma 1 square C1 bar and A1 dash. This is the frequency, this is the number of collisions made by first type molecule in unit time. Sigma 1 is the collision diameter of these first type molecules. C1 bar is the average speed of the first type molecules, and N1 dash the number density of the first type molecules, means number of first type molecules in unit volume. So for the calculations, let us find, whenever say here it is first type molecule and it is the second type molecules. This is the second type molecules, 2 and 2. Different gases will have the different molecular size. This is suppose bigger size, all are spherical, as you have assumed. Spherical, rigid, and they will move with the constant, and interpenetrable or non-interacting. So this is the center of this molecule. This one you can write sigma 1 2. Sigma 1 2 equal to sigma 1 plus sigma 2 by 2. This is sigma 1 by 2. This is sigma 1 by 2. This is sigma 2 by 2. So this one is sigma 1 plus sigma 2 by 2. This is this one. And when suppose this molecule is moving, first type molecules moving with the C1 bar speed, average speed. C1 bar is the distance traveled by the first type molecule in unit time. And let us suppose, it is also wrong supposition as we have done earlier, all the other molecules are at rest. Only this molecule is moving. So whenever this molecule is moving, we can consider another big sphere whose radius is sigma 1 2. And you, whenever this molecule is moving and other molecules are rest, so this will sweep a collision tube, and this is the area of cross section, and area of cross section, this one will be sigma 1 2, and this length of this heat cylinder will be C1 bar. Here other second type molecules, here they all the second type. The center of second type molecules, if they enter into this collision tube, then these molecules, the second type molecules will suffer collision with this one. Say similarly, suppose this is the just heat. This is suppose just miss to heat, and so on. So the cylinder, the volume of the cylinder, volume of the heat cylinder equal to pi area cross section, pi sigma 1 2 square. This is the area of cross section, and the length in 1 second time this molecule will move the C1 bar distance. So length of this collision tube will be C1 bar. So this is multiplied by C1 bar. And if this is the volume, and the number of collisions made by a single molecule of the first type with the second type molecules in 1 second time, this will give you the collision number of first type molecule with second type molecules equal to how much? This will be multiplied by the A2 dash. Say this pi and sigma 1 2 square and C1 bar and N2 dash. N2 dash is the number density of second type molecules. Means number of second type molecules in unit volume of this gas. So this will be this value Z1 and Z2. Z1 2 means first type collision number of the first type molecules with the second type molecules. The supposition that we have made is wrong. Only this molecule is moving and all other second type molecules are at rest. This is not right. This is to be rectified. As earlier, this will be pi sigma 1 2 square and sigma relative bar and N2. C1 bar is replaced by C relative bar. So in this case, the C relative bar, how would you get this C relative bar? And as you have this is first type molecule and this is second type molecules, and this angle is 90 degree, taking an average angle of collisions between head-on collisions and side-on collisions. So this one is C1 bar, this one is C2 bar, and this relative C relative bar will be equal to root over of C1 bar square plus C2 bar and square. So this will give you root over 8 KT by 5 M1, and this one will give you 8 KT by 5 M2. M1 and M2, these two are the molecular mass of this first type and second type molecules. First type and second type molecules. Plus this one. This you can write equal to root over of 8 KT by 5 into 1 by M1 plus 1 by M2. And you have seen probably when you are reading the Bohr's theory, this set 1 by M1 plus M1 plus 1 by M2 equal to 1 by mu. Mu the reduced mass of this molecule, reduced mass of the two molecules, mu. An expression of mu is given 1 by mu. This is the related with M1 and M2. So this could be written as root over of 8 KT by 5 mu. So this relative part is to be replaced by this value. So Z12, it is the number of collisions made by the first type molecule, single molecule, with second type molecules, and this one equal to pi sigma 1 2 square, and it is root over 8 KT by 5 mu and N2 dash. C relative bar is replaced by root over 8 KT by 5 M. However, we can also write this one pi sigma 1 2 square into root over 8 RT by pi 1 by m1 plus 1 by m2. This way also we can write m1 m2 are the molar mass of the first type and second type molecules, and this is and m2s. Now if we like to calculate the frequency of collisions between two unlike molecules, first type and second type, how many collisions are occurring in unit volume and unit time, then this to be multiplied by n1 dash. n1 dash, it is the collision made by a single molecule of the first type, but a unit volume contains the n1 dash number of molecules. So this Z12 equal to pi sigma 1 2 square root over of 8 RT by pi 1 by m1 plus 1 by m2, and here n1 dash n2 dash. This is the formula. Here 2 half is not to be multiplied, as it is the between two different type of molecules. So here double counting is not coming here, and so Z12 equal to pi sigma 1 2 square and root over of 8 RT by pi and 1 by m1 plus 1 by m2 and n1 dash and n2 dash. If we like to go from this to this, we can easily go there. It is more generalized than this one. Whenever we are going through from this to this, then sigma 1 2 equal to sigma 1 plus sigma 2 by 2, and in this case sigma 1 equal to sigma 2 equal to let this sigma. So it will be sigma 2 sigma by 2 sigma. And also this n1 dash equal to n2 dash equal to say a dash. Same molecule, like molecules. So in this case, this Z11, if we consider from here to here, then pi sigma square, and it is m1 2 by m 1 by m plus 1 by m 2 by m means 2 into 8 RT by pi m, and here also a into n1 n dash square. Whenever we consider the like molecules, it is to be divided by 2. So we are 2 taking out from this root over, then root over 2, and here 2, so it will be root over 2 pi sigma square and root over 8 RT by pi m equal to C bar, and it is n dash square. N dash square. So this formula is coming here. Now I shall consider, say, if you consider the mean free path of this first type of molecule, it will be the average distance traveled by the first type molecules. Average distance traveled by this molecule in unit time, and the frequency of the first type molecules is Z1 1 plus Z1. It is the collision, frequency of collisions. It is the collision made by the first type molecule with this first type, and it is the collision number of the first type molecules with second type molecules. If you try to calculate this lambda 2, then C2 bar, average distance traveled by the second type molecules in unit time, and this one will be Z21 and plus Z or Z22 and Z21. So you can put here these values and get this lambda 1 and lambda 2. Now next I like to say what would be the effect of temperature and pressure. Say Z11 equal to 1 by root 2 phi sigma square C bar equal to 8 RT by phi n into n dash. Instead of n dash, we can write this P into Avogadro number divided by RT and its square. So this Z1 sigma is taken constant, and m is also taken constant for this gas, fixed. And if we separate temperature or pressure, then it will be constant into T, and here P square and divided by 2 to the power P square and that 3 to the power 2. So at constant T, Z11 directly proportional to P square. Means if you double this pressure, if you double the pressure of this gas at constant temperature, then frequency of collisions becomes 4 times. Frequency of collisions becomes 4 times if you double this pressure. And similarly, this Z12 will also have the same variations with the temperature, pressure. And if you keep this pressure at constant P, Z11 proportional to 1 by T to the power 3. Means with the rise in temperature, constant pressure, this Z11 will decrease. If this one is increase, then this one is a decrease. Means temperature, whenever the temperature is increased, this volume will decrease. So this temperature is increased, the volume is increased, and Z11 will also be less. This is all about the today's lecture, and in my next class I will try to explain the law of equipartition of energy, which is very much useful to calculate the average energy of any molecule, considering the different type of degrees of freedom, translational degrees of freedom, rotational degrees of freedom, vibrational degrees of freedom, and so on. So thank you all who are watching my video with so much patience. I really thank to all of you.